Assalamu alaikum. My name is Abdulhamid Mahmoud Muhammad, and my next name is PE18004. Introduction. The convolution neural network, or CNN, is a form of artificial neural network that is particularly intended to analyze the pixel input and is used in an image recognition and processing. It is a deep learning system that can take an input image, assess the priority to distinct features of the image, and distinguish between them. The goal of this report is to collect photos of a specific waste materials and identify them properly. Nevertheless, it is a good impact on the environment and the economic, thus directly supports environmental sustainability. Methodology. The method used in this project is Convolutional Neural Network, or CNN, and before the task is started, the machine, VGG and ResNet have been trained for all the directions. As you can see, this is the VGG architecture, and this is formula for ResNet.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amizari bin Abdul Samad, AE180019. So for task 2, two model that we use for this task is VGG and ResNet. So first model is VGG. First step, we need to connect to Google Drive and feed dataset directory. And third step, we need to create the train and validation data directory. So for this process, the result we obtain is scan train length is 156, pet train length 310, scan validation length 77, pet validation length is 133. Next step, we need to construct pre-trained model with VGG. For this model, the total parameters we obtain is 18910.017, train parameter 4195329, non-trainable parameters is 14714.688. Next step is pre-process the input data. For this process, the result we obtain is 466 images found belonging to two classes, 210 images found belonging to two classes. Database shape is 20, 150, 150, and 3. Label base shape is 20. Next, we start training process. For this process, step per epoch equal to 10 and epoch equal to 10. So this is the result. For plot the outcome, the last step is plot the outcome. From this process, we obtain two graphs, which is training and validation accuracy, and the second graph is training and validation loss. So this is the result. For second model is ResNet. First step, we need to connect to Google Drive and feed dataset directory. And next step is we need to create train and validation data directory. So for this process, the result we obtain is scan train length equal to 156, pet train length equal to 310, scan validation length equal to 77, pet validation length equal to 133. Next step, we construct a pre-trained model with ResNet. So from this process, we obtain the total parameters equal to 46x03137. Trainable parameter equal to 26215.425. Non-trainable parameters equal to 235x7712. Next process is pre-process the input data. This process result is 466 images found belonging to two classes, and found 210 images belonging to two classes. The database shape is 20, 105, 150, 150, and 3. Label base shape is 20. Next step, we start the training process. For this process, step per epoch equal to 10. Epoch equal to 10. So this is the result for the epoch. Last step is we need to plot the outcome. For this process, we obtain two graphs, which is training and validation accuracy, and second graph is training and validation loss.
Assalamualaikum dan selamat sejahtera. My name is Aini Shafinas binti Mama Zahari. My matric number is CE190225. Okay, today I present about recyclable material classification by using convolutional neural network. We are required to design the CNN model to train the data without overfitting or underfitting. Okay, for task 1, step 1, we need to connect to Google Drive. Step 2, feed dataset directory. Step 3 is create, train, and validation data directory. This is our file in Google Drive, and our result is can train length is 156, pet train length is 310, can validation length is 77, pet validation length is 133, and we import the TensorFlow. Then step 4, construct the CNN model. Our result is total params is 19034177. Our trainable params is 19034177. Then non-trainable params is 0. Next is step 5, pre-process the input data. Okay, the result is we found 466 images belonging to two classes, found 210 images belonging to two classes. Data batch shape is 20, 150, 150, and 3. Label batch shape is 20. Next, step 6 is start training process. Our effort is 10. Effort 10 over 10 is loss is 0.0199. Our accuracy is 0.9914. Validation loss is 0.2887. Validation accuracy is 0.9143. And lastly, the step 7 is plot the outcome. This is our graph. This is a graph for training and validation accuracy, and second graph is training and validation loss. Okay, for task B, the step is same in the previous task. Just added 3 picture. Okay, for step 1, we connect to the Google Drive. Step 2, feed data directory. Step 3, create, train, and validation data directory. This is our file in Google Drive, and added a new CanPad directory. Okay, our result is can trend length is 156, pet trend length is 310, can validation length is 77, pet validation length is 133, and new can pet length is 3. And then we import the TensorFlow as the TF. Then step 4 is construct the CNN model, and our result is same in previous. Total param is 19034177, trainable params is 19034177, and non-trainable params is 0. And next is step 5 is pre-process the input data. Our result is found 466 images belong to two classes, found 210 images belonging to two classes, data batch shape 20, 150, 150, and 3, and label batch shape is 20. And next, then step 6 is start training process. Our effort is 10, and effort 10 over 10 is our loss is 0.0416, accuracy is 0.9850, validation loss is 0.3388, and validation accuracy is 0.9143. And next, for the step 7 is plot the outcome. This is our graph for the task B. This is graph for training and validation accuracy. And next, second graph is training and validation losses. And for the last step is fit sample image to observe which pet or can is dominant. First, we need to from Google Colab import files. Then this first condition is pet and can stay same distance from the camera screen. This our file in Google Drive. Then the result is this image is 100% can and 100% pet and display image this. And second condition is can stay and pet move further backward, and this is our file in Google Drive, and the result is this image is 100% can and 100% pet. Okay, this our image can stay and the pet move further backward. And lastly, third condition is pet stay and can move further backward. This our file in Google Drive. Okay, the result is the image is 100% can and 100% pet. Okay, this is display image for pet stay and can move further backward. Today I will present about convolution. We can summarize that the convolution neural network is a good platform for the deep learning algorithm. The design of CNN is inspired by the arrangement of the visual cortex and is similar to the connection pattern of neuron in human brains. In other terms, it may be programmed to better grasp the advanced feature of the picture. The CNN is exceptionally good at lowering the number of parameters without sacrificing model quality. The picture also has a high dimensionality. That's all from me. Thank you.